Lake Bennett, 1898. While 30,000 stampeders threw up quick cabins and rough shelters before the brutal Klondike winter locked them in, one freight veteran was still stitching canvas in late October. His neighbors called it circus work. They called him a fool wasting good material. He was sewing wagon covers and tarps into one massive sheet, big enough to wrap his entire 12 by 16-foot cabin like a tent pitched over a house. He staked it out 2 feet from his log walls on all sides, creating an air gap that looked like nothing but empty space. Then November arrived with temperatures plunging to 67 below zero. Wind screaming across the tent cities, driving cold through every crack and gap in standard cabins. Men burned through cord after cord of precious firewood, 128 cubic feet of stacked wood disappearing like smoke. But that fool's cabin with its flapping canvas shell? He was burning half what his neighbors did. His woodpile still standing tall while theirs dwindled to nothing. What did he understand about wind, heat loss, and survival that everyone else missed when they dismissed his tent-over house as wasted canvas and wasted time? If you value stories of practical wisdom that stood the test of time, make sure to subscribe. We've got more documented accounts worth remembering. Comment your city and time. We love reading where these documentaries reach. The canvas snapped like a ship's sail in the screaming wind, but the small log cabin beneath it held steady in the bitter Klondike night. Around Lake Bennett, 30,000 stampeders huddled in whatever shelter they could manage. Rough cabins, patched tents, and lean-tos that barely kept the snow out. Most had thrown up their structures fast and crude, racing against the early freeze that would trap them here until spring breakup. But this cabin was different. It wore a second skin. The freight veteran stepped outside with his lantern, boots, crunching through snow that had drifted 3 feet deep against his neighbor's walls. The wind hit him like a physical blow, driving ice crystals that stung his face even through his wool scarf. All around the tent city, stovepipes glowed red-hot in the darkness, pulling hard as bellows while men inside fed wood to hungry fires. Smoke leaked through every crack and gap in the hastily chinked walls, visible proof that heat was escaping as fast as it was made. The sound of splitting wood echoed across the frozen lake, the desperate rhythm of men who knew their lives depended on keeping those fires burning. He checked his own woodpile by lantern light and allowed himself a moment of satisfaction. While his neighbors had already burned through 2 cords each, his stack still rose shoulder high against the cabin's north wall. The canvas shell around his structure fluttered and strained against its stakes, but it was holding. More importantly, it was working. The air gap between his log walls and the outer canvas measured exactly 2 feet all around, not an inch more or less. He had learned this measurement through hard experience on freight runs, where wind could turn a warm wagon into an icebox in minutes. The principle was simple enough that any teamster understood it. Moving air steals heat faster than still air. A log wall might be 8 inches thick and tight chinked, but if wind could wash across its surface and drive cold air through the smallest gaps, that wall became a pump, pulling warm air out of the cabin and forcing frigid air in. The canvas took the wind's full force, creating a buffer zone of calmer air around the actual structure. Inside that pocket, his cabin walls could do what they were built to do, hold heat instead of fighting a losing battle against every gust that screamed across the lake. The difference showed in his woodpile, in the steady warmth inside his cabin, and in the envious glances from neighbors who had mocked his methods just weeks before. He remembered their laughter when he had first started stitching wagon covers together in late September. "Looks like a circus tent," one man had called out. "Sailor's gone crazy with his needle," another had added. They had built their cabins the standard way, single-wall logs, chinked with moss and clay where materials allowed, roofed quickly with whatever boards or canvas they could salvage from their trail supplies. The philosophy was universal among stampeders: build fast, improve later, survive winter however you can manage. But the freight veteran had watched too many camps where men burned themselves poor trying to heat the outdoors. On wagon trains, he had seen teamsters wrap their loads with double canvas to keep goods dry and stable. The principle worked for freight. Why not for shelter? Air, he knew, was the finest insulation nature provided, but only if you could keep it still. Moving air became an enemy that stole heat through convection and drove moisture deep into any gap it could find. So while his neighbors raced to complete their structures before the snow flew, he had taken time to engineer something different. The canvas shell required nearly 40 yards of material, precious wagon covers, worn tarps, and tent cloth that other men considered too valuable to risk on an experiment. He had reinforced the stress points with double-sewn seams, created a collar around his stovepipe opening that would not char, and designed a ridge system that would shed snow without collecting dangerous ice loads. The staking pattern had required careful measurement. Posts driven every 3 feet around the cabin's perimeter, positioned exactly 2 feet out from the log walls. Too close, and the canvas would touch the logs when wind pressed it inward, creating a thermal bridge that would wick away heat and trap moisture. Too far, and the air gap would become too large to maintain the calm pocket effect he needed. The bottom edge of the canvas skirt had to be sealed against the ground with banked snow, not to keep air from moving, but to control how it moved. When the temperature dropped to 20 below in early November, the first real test began. Neighboring cabins started showing frost lines on their interior walls, a sure sign that heat was escaping faster than their stoves could replace it. Men were burning 4 cords of wood where 2 should have sufficed, and still waking to ice on their water buckets. The veteran's cabin, wrapped in its fluttering canvas shell, maintained comfortable temperatures while his wood consumption remained steady and manageable. By the time the mercury hit 40 below, then 50, then the killing 67 degrees below zero that would define this winter, the contrast had become impossible to ignore. The canvas-wrapped cabin was not just warmer, it was provably more efficient. Where neighbors burned through 128 cubic feet of stacked firewood every few days, he stretched the same amount twice as long. The mathematics were frontier simple. Less wood burned meant more wood saved, and more wood saved meant a better chance of surviving until spring. The technique worked because it addressed the real problem. Most stampeders treated cold as something to fight with more fire, thicker chinking, or additional layers of clothing. But the freight veteran understood that wind was the enemy, not cold air itself, but moving cold air that could strip heat from any surface it touched and force its way through gaps no bigger than a knife blade. Stop the wind from reaching the cabin walls, and suddenly a modest fire could heat a space instead of heating the entire Klondike territory. As he walked back toward his door, the lantern light caught the canvas walls rippling in the wind like a living thing. Inside, his fire burned steady and low, requiring only a stick or 2 every hour to maintain warmth. Around the tent city, red glowing stovepipes marked the locations of men who were learning, one expensive cord at a time, that frontier building was more than just piling logs and hoping for the best. The tent cities that sprawled across the frozen lakes represented the largest bottleneck in Klondike history. 30,000 stampeders had pushed through the mountain passes only to find themselves trapped by early ice, forced to wait out the brutal winter in whatever shelter they could manage, before the spring breakup would allow them to continue downriver to Dawson. The shoreline settlements at Lake Bennett and Lake Linneman had exploded from wilderness to crude metropolis in a matter of weeks, creating a desperate economy where every decision came down to a simple calculation: build fast or freeze. Most men followed the same formula that had served frontier builders for generations: cut logs to length, notch them rough, stack them high enough to stand upright inside, and fill the gaps with whatever chinking material could be found. Moss stripped from trees, clay dug from the shoreline, old clothing, newspapers, even snow packed tight. Anything to stop the wind from pouring through the inevitable cracks between logs. Roofing came next, usually a combination of split boards and canvas salvaged from trail supplies, sloped just enough to shed the worst of the snow. The entire process, done fast and crude, could put a man under cover in 3 weeks if he worked alone, less if neighbors pitched in. Speed mattered because winter was already closing in by the time most stampeders reached the lakes. The Canadian authorities had required each man to carry a year's worth of provisions, roughly a ton of food and equipment per person, which meant the successful arrivals were those who had managed their loads efficiently enough to reach the lakes before the snow flew. Prices for basic supplies reflected the bottleneck economics. Eggs sold for $1 each when they could be found. Flour commanded premium rates, and firewood became the unofficial currency that determined who stayed comfortable and who merely survived. The freight veteran had arrived in late September with his year's supplies intact and enough canvas to outfit a small wagon train. His background in overland freight had taught him to think in terms of systems rather than individual solutions. On the trail, a teamster learned quickly that keeping goods dry, stable, and secure required understanding how materials behaved under stress. Canvas was not just covering, it was engineered protection that had to flex without tearing, shed water without collecting ice, and maintain tension through temperature swings that could crack leather and snap rope. When he started cutting logs for his cabin, neighbors assumed he would follow standard practice. The timber around the lakes was mostly green wood, spruce, and pine that had grown fast in the short northern summers. It was workable, but far from ideal, prone to checking and shrinking as it seasoned, which meant even the best chinked walls would develop new gaps as winter progressed. Most builders planned to improve their chinking throughout the cold months, a continuous process of finding and plugging leaks as their structures settled and the wood dried. But the veteran had different ideas. He built his 12 by 16-foot cabin using conventional log construction, but as soon as the walls were up and roofed, he began what looked like the strangest project in camp. He spread wagon covers and tarps across the ground near his cabin and started stitching them together with the methodical precision of a sailmaker. The work required strong thread, careful seaming, and reinforcement at stress points where wind load would concentrate. He worked in the evenings by firelight, his needle flashing as he joined panel to panel in a pattern that gradually revealed itself as one enormous piece of cloth. The mockery started almost immediately. "Building a circus tent?" one neighbor called out as he watched the veteran reinforce a corner seam. "That's enough canvas to roof 3 cabins," another observed, shaking his head at the apparent waste. The criticism carried a sharp edge because materials were precious in the tent cities. Every piece of cloth had been carried over the mountains on someone's back, and canvas in particular served multiple critical functions: shelter, ground cover, tool wrapping, and emergency repair material for everything from boots to boat hulls. To men who measured resources by survival necessity, the veteran's project looked like dangerous extravagance. They saw him using 40 yards of perfectly good canvas on what appeared to be decorative excess, when that same material could have patched a dozen leaking roofs or provided emergency shelter for new arrivals who were still sleeping under the stars. The practical frontier mind rebelled against anything that looked like waste, especially when winter was closing in and every scrap of material might mean the difference between comfort and catastrophe. The veteran ignored the commentary and continued his work. He had calculated the dimensions carefully. The canvas shell needed to encompass his entire cabin with enough additional material to stake out properly and create the air gap that would make the system work. The stitching had to be bomber-proof because the finished shell would face the full force of Klondike winds that could exceed 60 miles per hour during winter storms. He reinforced every seam with double-fold construction, created grommets at regular intervals for the stake-down points, and fashioned a collar system around what would become the stovepipe opening. His knowledge came from practical experience with wind-driven heat loss. On freight runs across the plains, he had learned that a wagon load could freeze solid overnight if wind could reach it, while the same goods would stay workable if protected by a proper cover system. The principle was simple. Still air insulated, moving air conducted heat away. A log wall could be thick and well chinked, but if wind could wash across its surface and find even small gaps to exploit, that wall became a thermal highway carrying warmth outside and cold inside. The veteran had watched camps where men burned themselves poor, trying to heat structures that leaked heat faster than any reasonable fire could replace it. Stoves glowing red-hot around the clock, wood disappearing at rates that turned men into full-time fuel gatherers, and still the interior temperatures that barely stayed above freezing. The problem was not insufficient fire. It was uncontrolled air movement that turned every crack into a thermal drain and every gust into a pump that exchanged warm interior air for frigid exterior air. As he worked on his canvas project, neighbors continued building and improving their cabins using time-tested methods. They added extra chinking, banked snow against their foundations, and stockpiled wood at rates that reflected their understanding of winter fuel consumption. Most had calculated their needs based on frontier rule of thumb: 1 cord of wood per month for a small cabin in serious cold. With winter stretching from October through April, a prudent man would have 6 cords split and stacked before the deep cold arrived. The veteran's woodpile looked adequate, but not excessive by camp standards. His neighbors, working their calculations, figured he would be begging for fuel by January, or cutting green wood in sub-zero temperatures. A dangerous and inefficient proposition that had killed men in previous northern winters. They watched his canvas project with the mixture of amusement and concern that frontier communities reserved for innovations that looked clever but untested. In a place where proven methods meant survival and experiments could mean death, the veteran was about to stake his winter comfort on a theory that most men would have dismissed as impractical foolishness. The finished canvas shell measured 32 feet long by 24 feet wide when spread flat, large enough to drape over the veteran's entire cabin with material left over for proper staking. The construction had required precise planning because once the panels were sewn together, there would be no opportunity for major adjustments. He had started with the roof section, creating a peaked cover that would follow the ridgeline of his cabin and shed snow without collecting dangerous loads. The wall panels attached to the roof piece with reinforced seams, dropping down like an enormous skirt that would surround the structure on all sides. The stitching itself represented weeks of careful work. Each seam required double-fold construction with heavy thread that could withstand the constant flexing of wind-driven canvas. The veteran used a sailmaker's technique, overlapping the fabric edges by 3 inches, and sewing 2 parallel lines of stitches to distribute stress across the joint. At the corners where his multiple panels met, he added triangular reinforcement patches to prevent tear-outs that could propagate and destroy the entire shell. The stovepipe collar required special attention, a circular opening with rolled edges and tie-down flaps that would seal around the pipe without creating a fire hazard. Installation began at first light on a calm October morning when the wind would not fight the process. The veteran had recruited 2 neighbors to help with the initial positioning, though their assistance came with continued commentary about the project's wisdom. He started by driving stakes in a precise rectangle around his cabin, measuring carefully to maintain exactly 2 feet of clearance from the log walls on all sides. The stakes went deep, 18 inches into ground that was already starting to freeze, and angled outward slightly to resist the upward pull that wind would create on the canvas. The spacing between stakes mattered as much as their placement, every 3 feet around. The perimeter, he positioned a stake with guy line attachment points that would prevent the canvas from developing the kind of rhythmic flapping that could tear fabric or work fastenings loose. Too few stakes and the canvas would sail in the wind, creating stress concentrations that would eventually fail. Too many stakes and the system would become rigid, unable to flex with gusts, and likely to tear at attachment points when the wind shifted direction. Raising the roof section required coordination and timing. The veteran climbed onto his cabin while his helpers positioned the canvas below. Then together they lifted the peaked cover over the ridgeline and settled it into position. The fit was close, but not tight. The canvas needed to clear the cabin roof by several inches to prevent contact that would conduct heat and moisture between the 2 surfaces. Once the roof was positioned, he secured it with a ridgeline rope that ran the length of the cabin and tied off at both ends to stakes, driven well beyond the main perimeter. The wall sections came next, unfolding like curtains around the cabin's sides. Each panel required individual adjustment to maintain the critical 2-foot air gap while ensuring adequate ground contact for the snow seal that would complete the system. The veteran worked methodically around the perimeter, attaching guy lines at each stake point and adjusting tension to create a uniform standoff distance. The canvas needed to be taut enough to resist flapping, but flexible enough to absorb wind gusts without transferring dangerous loads to the attachment points. The most critical detail was ensuring the canvas never touched the cabin walls. Contact at any point would create a thermal bridge that would conduct heat directly through the fabric and defeat the entire purpose of the air gap. The veteran checked each section with a measuring stick, verifying that wind pressure could not push the canvas close enough to contact the logs even during the strongest gusts. Where natural irregularities in his log work created tight spots, he adjusted the stake positions outward to maintain clearance. The bottom edge required a different approach than the overhead sections. Instead of rigid attachment, the canvas skirt simply draped to ground level where it would be sealed with banked snow once winter deepened. This arrangement allowed the system to breathe. Moisture from inside the air gap could escape while still maintaining the wind barrier that was the shell's primary function. The veteran cut small vent slots near the top of the wall panels to ensure air circulation that would prevent condensation from building up inside the buffer zone. The stovepipe installation tested the entire concept. The veteran had cut the collar opening slightly larger than the pipe diameter and reinforced it with a metal ring salvaged from a broken bucket. The pipe passed through the canvas without contact, and adjustable flaps allowed the opening to be sealed around the pipe while maintaining fire safety clearance. Heat from the pipe would warm the immediate area of canvas, but the metal ring would prevent the fabric from charring, while the air gap would keep the entire system from overheating. With the shell complete and properly tensioned, the veteran fired his stove for the first test. Inside the cabin, the temperature rose normally as heat from the firebox warmed the interior air. But outside, the effect was immediately visible. The canvas walls moved gently in the breeze instead of snapping and straining like tent fabric in a gale. The air gap remained stable and calm while wind gusted across the outer surface without penetrating to the cabin walls themselves. Most importantly, the heat being generated inside the cabin stayed inside, instead of being stripped away by air movement across the log surfaces. The mechanism worked like a double-pane window scaled up to building size. The outer canvas took the wind load and weather, exposure, while the inner cabin provided the actual living space. Between them, the 2-foot air gap created a buffer zone that minimized heat transfer between interior and exterior. Still air was nature's finest insulation, but only if it could be kept still. The canvas shell accomplished this by creating a dead air space around the entire structure, a thermal jacket that allowed the cabin's modest heating system to work efficiently instead of fighting a losing battle against Klondike wind. The veteran had essentially built a house inside a larger house using the same principle that frontier families applied when they built summer kitchens or winter rooms. But instead of constructing 2 separate buildings, he had used fabric and air to create the outer envelope. The result was a cabin that could maintain comfortable temperatures while consuming roughly half the fuel that neighboring structures required. The mathematics were simple. Less heat loss meant less fuel needed, and less fuel needed meant a better chance of surviving the winter with wood to spare. As the system settled into operation over the following days, neighbors watched with growing interest as the veterans' wood consumption remained steady while theirs continued to climb with the falling temperatures. The temperature began its deadly descent in the first week of November, dropping from the manageable cold of October into the killing range that would define the winter of 1898. 20 below became 30 below, then 40, as an Arctic high-pressure system settled over the Yukon Territory and refused to move. The tent cities along the lakes transformed from bustling frontier settlements into survival camps where every decision revolved around fuel conservation and heat retention. Men who had arrived with confident plans for wintering in comfort found themselves burning through wood at rates that threatened to leave them defenseless against the months of cold still ahead. These conventional cabins began failing first, not through structural collapse, but through thermal breakdown that made them uninhabitable despite the desperate efforts of their occupants. Frost lines appeared on interior walls where breath and body heat condensed against surfaces chilled by exterior cold. Ice formed in water buckets placed just feet from glowing stoves. Drafts that had seemed minor in October became torrents of frigid air that no amount of additional chinking could stop. The gaps between logs, invisible during construction, opened and widened as the green timber dried and shrank in the relentless cold. Stovepipes throughout the tent cities glowed cherry red in the darkness as men fed their fires with desperate intensity. The sound of splitting axes echoed across the frozen lakes from before dawn until well after dark as neighbors who had started winter with adequate wood piles found themselves cutting into reserves they had planned to save for the deep cold of January and February. The mathematics were brutal and simple. A conventional cabin in 60 below weather could consume a full cord of wood every 10 days, turning a 6-cord winter supply into fuel for 2 months instead of 6. The veteran's canvas-wrapped cabin presented a stark contrast to the fuel-burning desperation around him. His stove required feeding every few hours instead of every few minutes, and the interior temperature remained stable enough that water stayed liquid overnight. The canvas shell rippled and strained against its guy lines, absorbing the wind's energy without transmitting it to the cabin walls beneath. Snow had begun to accumulate against the canvas skirt, creating the ground-level seal that completed the thermal envelope and eliminated the last pathways for cold air infiltration. Inside the air gap between canvas and logs, the temperature differential was measurable and dramatic. While exterior air might reach 50 below zero, the buffer zone maintained temperatures 20 to 30 degrees warmer, simply by being protected from wind. The veteran could verify this by touch when he checked the stake lines during storms. The canvas felt cold, but not the bone-numbing cold of direct exposure to moving air. The principle was working exactly as he had calculated. Still air insulated, while moving air conducted heat away at rates that overwhelmed any reasonable heating system. By mid-November, when temperatures hit 57 below zero and stayed there for a week, the contrast between heating systems became impossible to ignore. Neighbors were burning through 128 cubic feet of stacked firewood every few days, while the veteran stretched the same amount more than twice as long. His wood pile, which had looked adequate but not excessive by camp standards, remained substantial, while others dwindled toward emergency levels. The men who had mocked his canvas project now watched his consistent fuel consumption with the kind of attention that frontier survival demanded. The crisis deepened when the mercury dropped to 67 below zero, a temperature that challenged even the best-built structures in the tent cities. At that extreme, conventional heating systems failed not through lack of fuel, but through the impossibility of generating heat faster than wind-driven convection could strip it away. Stoves designed for normal winter conditions became inadequate for the heat loads imposed by uncontrolled air movement. Men found themselves feeding fires continuously, burning green wood that produced more smoke than heat, and still waking to ice on their interior walls. The veteran system proved its worth during the worst of the cold snap. His interior remained comfortable enough for normal activities while neighbors struggled to stay warm despite burning wood around the clock. The canvas shell, now weighted with accumulated snow and ice, created an increasingly effective barrier that isolated his cabin from the exterior weather conditions. The dead airspace had become a thermal jacket that allowed his modest heating system to maintain livability instead of merely fighting for survival. Wind effects that devastated neighboring cabins barely registered inside the veteran's thermal envelope. Gusts that drove snow through the smallest cracks in conventional structures could not penetrate the buffer zone that surrounded his cabin. The canvas absorbed and dissipated wind energy, while the air gap prevented the mechanical transfer of cold that turned other cabin walls into heat sinks. His heating system worked as intended, warming the interior air and maintaining that warmth, instead of attempting the impossible task of heating the entire Klondike territory through thermal leakage. The fuel mathematics became a camp-wide conversation as men calculated their remaining supplies against the months of winter still ahead. Those who had started with 6 cords were finding themselves with 3 cords, remaining before December even arrived. Emergency cutting parties ventured onto the frozen lakes to harvest driftwood, working in temperatures that could freeze exposed flesh in minutes. The veteran, meanwhile, maintained his steady consumption rate that suggested his original wood supply would last through breakup with fuel to spare. Neighbors began timing their wood-splitting sessions to coincide with the veteran's outdoor maintenance checks. They watched him inspect his guy lines and canvas, tensioning with the methodical attention of a man whose system was working as designed. His stakes remained solid despite the ground frost. His canvas showed no signs of stress failure, and his stovepipe drew steadily without the violent drafting that characterized overworked heating systems. Most telling of all, he was not cutting additional wood during the coldest weather, while men around him worked in dangerous conditions to maintain their fuel supplies. The social dynamics of the tent cities began shifting as the heating crisis separated the prepared from the desperate. Men who had dismissed the veterans' methods as wasteful excess now approached him with questions that carried the weight of survival necessity. The mockery had stopped completely, replaced by the calculating attention that frontier communities reserve for techniques that might mean the difference between making it through winter and becoming another cautionary tale about inadequate preparation. The canvas shell had proven itself under the most extreme conditions the Klondike could deliver, demonstrating that wind control was not a luxury, but a fundamental requirement for efficient heating in serious cold. The first approach came during a particularly bitter morning, when the temperature had not risen above 55 below for 3 consecutive days. A neighbor who had been among the loudest mockers of the canvas project appeared at the veteran's door with his hat in his hands and a question that carried the weight of desperate necessity. His own cabin had become barely habitable despite burning wood at rates that would exhaust his winter supply before January ended. The frost on his interior walls had grown thick enough to scrape with a knife, and his family was sleeping in shifts to keep the fire fed through the night. The veteran did not lecture or remind the man of his earlier skepticism. Instead, he walked him around the canvas-wrapped cabin, pointing out the stake positions, the air gap maintenance, and the snow banking that sealed the system at ground level. He explained the measurements in practical terms that any frontier builder could understand. 2 feet of standoff distance, stakes every 3 feet around the perimeter, guy lines tensioned to prevent flapping but loose enough to flex with wind gusts. Most importantly, he emphasized the principle that made it work. Wind was the enemy, not cold itself, and stopping wind from touching the cabin walls was as important as the walls themselves. Within a week, 3 other neighbors had approached with similar requests for instruction. The veteran spent his evenings teaching men to stitch canvas panels with the double-fold seaming that would survive winter wind loads. He showed them how to reinforce stress points with triangular patches and how to create stovepipe collars that would not char under normal heating conditions. The work required patience and precision, but the materials were available throughout the tent cities. Most stampeders had carried extra canvas for emergency shelter, and wagon covers damaged during the mountain crossing could be salvaged and repurposed for the outer shells. The tent city seamstress who ran a canvas repair operation near the lake shore found herself overwhelmed with requests for instruction in heavy-duty stitching techniques. Men who had never held a needle were learning to join panels with seams that could withstand the mechanical stress of wind-driven fabric. She taught them sailmakers' techniques for distributing loads across multiple attachment points and showed them how to create grommets strong enough to hold guy lines under storm conditions. Her small operation became an informal training center where the practical knowledge of canvas work spread through the camp. The adoption process moved faster than typical frontier innovations because the mathematics were immediately visible and measurable. Men could see the veterans' wood consumption compared to their own, and they could calculate the difference in terms that mattered: cords saved, hours of wood cutting avoided, and margin of safety that could mean survival if the winter stretched longer than expected. A technique that cut fuel consumption in half was not a convenience. It was a multiplier that doubled a man's chances of making it through to spring breakup. By late December, a recognizable pattern had emerged along the shoreline settlements. Row after row of cabins sprouted canvas shells as men implemented variations of the veteran system. Some used military tent canvas, others stitched together wagon covers and tarps, and a few experimented with double layer arrangements that created insulation within insulation. Not every attempt succeeded. Canvas that touched the cabin walls created thermal bridges that defeated the system, and inadequate staking led to failures during windstorms, but the successful installations proved the principle again and again. The wood camp cutters who supplied fuel to the tent cities noticed the changed demand patterns before anyone else. Men who had been burning through cords at emergency rates suddenly required half as much wood to maintain livable conditions. The cutting crews, working in temperatures that made outdoor labor dangerous, found themselves with surplus inventory for the first time since the deep cold had arrived. The fuel economy of the entire region shifted as efficient heating became the norm rather than the exception. Among those who had adopted the canvas shell method, the boat-building foreman who supervised construction crews preparing for spring breakup became one of the system's most vocal advocates. His workers spent long days in the open, building the vessels that would carry 30,000 stampeders downriver to Dawson when the ice went out. Men who were burning themselves poor heating, inefficient cabins had less energy for productive work, while those who had solved their heating problems could maintain the consistent output that boat construction required. Efficiency in one area supported efficiency in another, and the canvas shell technique became part of the camp's survival infrastructure. The regional context made the innovation even more significant. The Yukon River stern-wheel steamers that supplied the territory consumed roughly 120 cords of 4-foot wood per trip from Whitehorse to Dawson, demonstrating the industrial scale of fuel demand in the northern economy. Every cord saved at the household level represented resources that could support other essential activities, boat building, equipment maintenance, and the countless tasks that prepared men for the final push to the gold fields when navigation resumed. Modern thermal engineering would later validate the veterans' intuitive understanding of wind control and layered insulation. The Department of Energy would recognize the principle he had discovered. The controlling air movement around a structure was as critical as the insulation properties of the structure itself. His canvas shell had created what engineers would call a thermal break, an air gap that interrupted the conductive heat transfer between interior warmth and exterior cold, while eliminating the convective losses that wind created across building surfaces. The legacy of the technique extended beyond the immediate crisis of the 1898 winter. Men who learned the canvas shell method during the Lake Camp months carried the knowledge with them to Dawson, to other mining districts, and eventually to frontier settlements throughout the Northern Territories. The principle that wind control was fundamental to efficient heating became part of the practical knowledge that separated successful northern builders from those who struggled against the climate instead of working with it. In the spring, when breakup finally freed the tent cities from their ice prison, many of the canvas shells remained in place. Men who had experienced the difference between efficient and inefficient heating were reluctant to abandon systems that had proven themselves under the most extreme conditions the Klondike could deliver. The veterans' innovation had become standard practice, transforming from mocked experiment to essential survival technique in the span of a single brutal winter. The lesson remained frontier simple and universally applicable. In a real winter, you do not just insulate a house, you keep the wind from touching it.